15.3, we're going to learn the concept of dilution. So dilution means that in the process, we add water into a solution. For example, in this case, we have like 8 particles in the solutions, and then after we add water in it, we'll know that the concentration of the solutions will then goes down. But why is happening like this? So first of all, you can see that right here we have 8 particles. So after I add water, after the dilution, how many particles do we have in it? So I think the answer is quite easy. You'll find that we still have 8 particles in it, because the particle cannot leave the solutions, it only stayed there. And also in the process, we just only add water, so therefore the number of particles, it won't increase. So therefore these 8 particles will still stay inside. So we can see that in the process, the volume V1 or before dilution will be like that. After we add water, definitely the volume will go up. So we will find that the volume will be increased. So V2 will be larger than V1, right? So the other things you will find that the number of particles actually before dilution and after dilution is the same. So we will say that number of mole before dilution will equals to the number of mole after dilution. And we also learned that number of mole equals to M times V. So therefore we will know that MV equals to MV. To distinguish before and after, we use number to show. V1 and V2 means before dilution, after solutions, dilutions, the volume, and the molarity, because we know that after we add water in it, the molarity will also change. So therefore we have M1 and M2 as well. Basically, we will find that before dilution we have 8, after dilution we have 8 particles as well, but the volume will changes in the process. Number of moles before and after should be the same. So therefore we will have this equation, M1 equals to M2, M1V1 equals to M2V2. So whenever we see questions having like keywords of the question, whenever you see they have the word like dilute or dilution, or maybe add water in it, then we will see that that will be the question related to dilution. And in the case, we'll quickly use this equation, M1V1 equals to M2V2, to help us to solve the problems. So have a look at the first questions. So 100 cm cube 2.5 molar sodium hydroxide is diluted to. You can see the question words. So therefore we quickly use the equation, M1V1 equals to M2V2. You have to identify which one is before dilution, which value is after dilution. So we know that 100 cm cube 2.5 molar sodium hydroxide is diluted to 250. So this one is after dilution, this one is before dilution. So I can identify this one as V1, this is M1, and then this one will be V2. So what you're looking for, molarity, that will be M2. So you put the value in it into the equation, that it can help you to solve the problem. So this one should be 2.5, and then volume it should be 100 over 1000 to put it in dm cube, because you know that molarity is mole per dm cube. So therefore when you multiply the volume also have to be in dm cube values. So this one, and then will equals to M2, the one that we're going to find, and then 250 over 1000. So after solving the question, so M2 will equals to 1.0 molar. So basically when you see dilution, you have 2 techniques. One, apply the equation. Number 2, identify which one is V1, V2, M1, M2, and then you put it in it, will do. So but one question is quite tricky. That will be a trap. Remember, whenever you deal with the questions volume to be added, that means how much water you have to add in it. So we just get back to this picture. You find that this is V1, this is V2. Whenever you ask volume to be added, how much volume of water we have to add in it, you may think that, that will be the nude volume. Of course not, because volume to be added, it have to be this amount, because we have original V1 amount, okay, of water in it already. So the volume to be added will have to be this one, okay, the additional water added into it. So this one basically it will equals to volume to be added will equals to V2 minus V1, okay, V2 minus V1, okay. So very important, okay, when you talk about volume to be added, okay, you have to remember you have to do a subtractions in it. How the questions look like, have a look here. So what volume of water has to be added? So you can see the question words. So, and then you also see dilute. So therefore, quickly use M1V1 equals to M2V2 right there. So dilute 250 cm cube of 0.2 m nitric acid to 0.08 m. So this one would be before dilution V1, before dilution M1, and this one will be after dilution M2. Okay, so you're going to find out the volume V2 first. So we put things into the equation. Okay, remember change it to dm cube. So this one will be 0.08, and then we'll have V2 here. So V2 that we found will be 0.625, and this one will be in dm cube. Okay, so this one, if it is in dm cube, the volume of water added, so you have to separate, okay, to do the calculation. It will be equal to 6.025 minus 6.250. Okay, I just divide this one by 1000. Okay, and then the answers for this one, it will be 375 cm cube, or you can say 0.375 dm cube. Both will be all right. Okay, so these are questions. Okay, remember you have to do the subtractions, V2 minus V1, then you can find the volume of water added. So last part, okay, that will be not related to the dilutions, okay, more or less, okay, is related to the free path diagram. So this one, okay, find the molarity of the constituent ions, okay, the ions made up of the compound in 1.5 m copper 2 chloride solutions. So copper 2 chloride, how many ions do we have in it? Okay, it should be CuCl2. If we break it up, we'll find it Cu2 plus and also 2 Cl minus. Okay, so in total, okay, we have 3 ions in it, okay, including the cation and also the anion. So basically, okay, in this sections, okay, you just use these calculations. Okay, you know the molarity right now is 1.5 m, so the molarity of the ions will be times n. N will equals to 3 in this case because we have 3 constituent ions. So basically you need to do is 1.5 times 3, and you'll find that it will be 4.5 m. Okay, that one is for ions in general. If the question is changed to like cation, then how many cation do we have? Okay, we have like 1 cation. How many anion do we have? We have like 2 anion. So for cation, it will then be 1.5 times 1, so it would be 1.5 m cation. If it is anion, then if it is anion, because we have 2 in it, okay, so it will be 1.5 times 2, then it will be 3 m anion. Okay, it really depends on what kind of ions you're talking about. Okay, and then you time the corresponding numbers, okay, in each particle. So basically, okay, you can do some self-tests, okay, in the test book. So 3 of them with the answers here. Okay, I'm not going to explain this one, okay, with you because it's pretty easy. Okay, just pay attention to volume of water has to be added. Okay, you have to use the concept V2 minus V1, and then you also have some more exercise. Okay, just go through this on your own. So summary, okay, remember before dilution and after dilution, the number of particles should be the same. Okay, you just add water in it. So the most important concept here, okay, that will be M1V1 equals to M2V2. Second one is about the trap. Okay, remember when you ask about the volume of water added, remember you have to do subtraction, V2 minus V1. Lastly, okay, when you want to find the molarity of the constituent ions, cation, anion, whatever it is, okay, so you have to use this part, okay, to multiply by n, okay, only these 3 things, okay. The calculations in this chapter should not be that difficult, okay. So that will be the end of chapter 15. Okay, time for you to finish the notes and also finish the chapter exercise. Okay, that's all for this video. Bye bye.